Hello, my name is Arturo Schleis, and today I'm gonna share with you the overview of the current landscape of Unity engineering. Basically, how people are writing games these days. So, Unity has its own style of development of software engineering, and from my experience, the Unity usage, the way Unity games are written, tends to fall into one of two patterns. So one is the Unity style entity component system, ECS, and it's the original way of developing with Unity. It has been with us since the version 1 of Unity. It is object-oriented in imperative. And basically we have these entities which are known as game objects in Unity. And then the component in the system part from the entity component system is the mono behavior. Mono behaviors are components because they have the data, and they are also the systems, sort of, because they have the callbacks that allow them to actually do things. So you have your update, you have your start, physics callbacks, all of these, which can actually allow you to do something interactive instead of just having some data. And then there's the next generation DOTS style, data-oriented technology stack, ECS, which is oriented at the fast computation and parallelism. So it's basically built so you could have thousands of entities on screen, or maybe tens of thousands. It is not object-oriented anymore. It is data-oriented, as in the name, but it is still imperative. And it's kind of marketed or said to be the future way of developing with Unity because of the performance benefits and the capability to use multiple cores of your computer. And both of these styles, they actually work pretty well, for gameplay code. So for things that, actually make the core of the game, like running, shooting, all of these things. And this gameplay code is usually concerned about object identity. So what that means is if you have, let's say, a space top-down shooter or something, and there's two spaceships in the game, they will be considered distinct even if they're, aligned pixel perfect at the same coordinate, they have the same hit points, they have the same stats, but they are still two different things. That means they have two different identities, even though the data is essentially the same. And gameplay code also does a lot of updates every frame. So, every frame there's something happening, there's units moving, there's health points being updated, things like that, as I've mentioned. And then that type of code often does not require complex relationships. So, there might be like if a projectile hits a unit, then the health points should be removed, or, if there's a door, it should interact with the character, things like that. But these interactions are often fairly simple and fairly not very complicated. So the Unity way, this imperative programming, whether it should be with the original Unity way or with the DOTS stack, it is a great paradigm for gameplay programming. However, games are not only gameplay. They are also there's often a metagame around the main game loop. So, upgrades, progression through the game, there's economies, things like that. Sometimes economy is, the whole game in cases of like city builder games. There's also the infrastructure like configuration and content systems for live operations, for delivering content throughout the lifetime of the game. There's orchestration between different parts of the game. So, very often you will have a game split into these little pieces, and somehow you have to tie everything together. You have to load things, unload things at the right time. There's user interface code. especially if you think of a game like, for example, EVE Online or any city builder game. There's a lot of user interface code. There's a lot of tables, windows, charts, things like that. And in fact, from our experience, in our games, the UI code, the user interface code, is actually usually a much bigger part of the code base of the whole code that's written in the game than the actual gameplay code. So the gameplay code is like, I don't know, 40%, and then the UI part is 60%, or UI plus infrastructure. And unfortunately, imperative programming, the whole monobehavior entity component system stuff, is really a very suboptimal paradigm for all of those things. And it really shows. So games are known as very, buggy pieces of software. And if you go to any app store or something, you will see that there's plenty of reviews where basically people are complaining that the game itself sort of is great, but the game has to reload often, and you can watch ads but nothing really happens, and the game crashes 50% of the time you watch an ad. Cyberpunk 2077 was like notoriously buggy, like hilariously buggy, I would even say, upon its launch. And even at 1 year has passed, and they haven't able to fix all of the bugs. And there's another case like this, and another case like this, and another case like this. Can't train anything. There's an error that pops up when you try to train. Ubisoft had Assassin's Creed bug-ridden. Warcraft 3 Reforged was a very interesting case as well. And here we have Diablo Immortal and Call of Duty. So plenty of bugs, I guess. The question is, why does it matter? Why do we care at all? And my opinion is that, well, really nobody wants to play buggy games. And those buggy games result in, loss of sales and existing players. The existing players get frustrated, they want their refunds, or they go and write bad reviews. Those bad reviews are then read by new players. So, for example, me personally, if I see an ad for a game, I will go to the store and I will read the reviews first. And then if it says, it's unstable, crashy, buggy, things like that, I will not try out the game because I don't really want to waste my time here. So that's what makes it harder to attract new players to the game, whether it should be, sales of premium games or, attracting users to free-to-play games. And you can lose reputation. So CD Projekt Red previously, after Witcher 3 had stellar reputation, and it all kind of went down the drain after Cyberpunk 77. It also inflates business costs directly. So when you have a buggy game, all development kind of takes longer time. First, you have to go and try to fix the bugs. So you have to go and try to reproduce them, then find out the exact conditions, how they happen, then understand how your game gets into those conditions, then go and fix it, test it. All of this takes time and costs money. Also, developers very often become frustrated with this buggy code base. So it really depends on the person, but from my experience, a lot of the time people don't really like going in and catching those bugs. Sometimes they do. Some people look at it as it would be like a puzzle, like they're Sherlock Holmes or something, solving a case. But most people just become very frustrated. They like to build features. They like to build things that they can tell their friends about. And, I made this game actually behave how it is intended to do, to behave. It's not really a very, not a thing that you can kind of brag about, if you will. So they get frustrated by these bug hunts, and then After some time, they might say, you know, I have had enough. I'm going to go to another company where I will be working on something more interesting, which means, you know, you have to spend more time again on recruiting people and then onboarding them. And if you, from my experience, when you're onboarding someone, it usually takes at least 3 months to get them up to speed with your project, especially if it's, you know, a larger project, to make sure that they know where everything is and can work effectively. So that's direct business costs. Then, you know, if these developers leave, then the project suffers from brain drain. What that means is basically, you know, if you have a developer and he wrote something, maybe it's not perfectly documented, or maybe it's not very clear in the code how things work, but at least the developer knows how things work there. And if he leaves, he takes all of that knowledge with him away from the company, and then you can even have projects enter this state where nothing really works as it's supposed to work, and nobody really knows why, because, you know, the original people have quit and the new people can't really figure out because the code is too confusing, or due to other reasons, and then nobody can figure out how to fix these problems, and they just be there. And you've seen from the reviews previously that, you know, a year might pass and the bugs will not get fixed. So the question is, are we doomed? And when you look at it, you know, there's companies that have been working for years and they still make buggy games. Ubisoft was established in 1986, 36 years in business. You know, Blizzard 31, CD Projekt Red 28, InnoGames 15, Activision 43. All of these companies were the companies from the reviews in the previous slide. And when you think about it, I mean, if a company that has been in business for like 43 years still can't make a properly functioning game, I mean, surely there's no hope. It's impossible, right? Well, luckily, no. At least that's what I think. And to learn more, see you in the next video.